Now let's take a look at parabolas in general. We can have several different types of parabolas. In our class, we're going to be looking at parabolas that open up or down. We've seen those before in chapters 16 and 18. And we're going to be looking at parabolas that open left or right, and that's primarily in this new chapter 22. Moving into trigonometry or analytical geometry or calculus, you might see parabolas that are at a slant or rotated. We need a little bit more mathematics to talk about those kinds of parabolas, so that's why we're going to stick with up or down and left or right. Parabola that opens up or down, these are functions, and these we've already talked about. If a is positive, the parabola opens up. If a is negative, the parabola opens down. We have our standard form here, which is also known as vertex form, a times x minus h squared plus k. So our vertex is h comma k, and our axis of symmetry is x equals h. Remember, the axis of symmetry is a line that goes through the vertex that splits that parabola in half. The new parabolas that we'll be looking at are parabolas that open left or right. So if a is positive, the parabola opens right. And you can think about this in the positive axis direction. So positive x-axis direction, it's opening right. If a is negative, the parabola is going to open to the left. In our standard or vertex form for parabolas opening left or right, notice the placement of the variables here. This is important. So our standard form for a left-right parabola is x equals a times y minus k squared plus h. X and y have effectively switched places in the equation, and h and k have switched places in the equation. But the vertex itself, the vertex ordered pair, is still h comma k. The h goes with the x, and the k goes with the y. And then our axis of symmetry becomes y equals k, because again, we're wanting to split that parabola in half, so we want a horizontal line to split the parabola in half. Here's what we mean. Since we've done a lot of work already on up-down parabolas, we're going to be focusing in this chapter on left-right parabolas. In the first graph that opens right, a is positive, hk is my vertex, and I have this horizontal line going through the vertex y equals k. For opening left, same thing, hk is my vertex, horizontal line y equals k, but this time a is negative, forcing that parabola to open to the left. Okay. Keeping all of these in mind and thinking about how things change when we have an x equals equation, let's look at some graphs. Let's look at the first one, x equals negative y squared. We don't have any parentheses around the y. We don't have an adding of a number. If we try to make a table for this, we can make an xy table, but this time I'm going to pick values for y and plug them in for x. So if I choose 0 for y, I'm going to get back 0 for x. If I pick 1 for y, I'll get negative 1 for x, 1 squared, and then the negative 1 in the front. If I pick 2 for y, negative 2 squared would give me negative 4. And then I can repeat this on the other side of the 0. Negative 1 squared is 1, but then I've got the negative sign. Negative 2 squared is 4. And I've got the negative sign. So then I get a graph of a parabola like this. And we can see that since a is negative 1, which is less than 0, the parabola should open left. The vertex is 0, 0 because, as mentioned before, there are no hk values here. We just have x and y squared and a. So our vertex being 0, 0. And that means our axis of symmetry would be y equals 0, which is actually the x-axis here in the middle. Looking at number 6, x equals negative y squared plus 4. I'm going to write it a little bit differently this time. Y squared is the same as y plus 0 squared, and the plus 4 on the outside. So this essentially means that my vertex is 4, 0, and I can create another table of values. 4, 0 is my vertex, and I'll choose values for y and plug them in and find x. So 1 in for y, 1 squared is 1, negative 1 plus 4 is 3, and then plugging in 2, 2 squared is 4. Negative 4 plus 4 will give me 0. And then if we plug in the negatives, we'll end up with the same values by symmetry. So we can start to graph 4, 0, 3, 1, and 3, negative 1, 0, 2, and 0, negative 2. And a couple more things to point out. This parabola looks very much like that one. It's just been shifted in the x direction. Now, all of those shifting rules that we learned in the context of functions. These graphs are not functions. Recall, if I draw a vertical line, it can only hit the graph in one place to be a function. These are not functions. So those rules work differently here. Be aware of that. Some other things to note, we still have a negative, so it opens left. The vertex being 4, 0, my axis of symmetry will be y equals 0 again. Going back to what we talked about in context of functions, we have analogous formulas for these left-right parabolas. We don't have function notation, but we do have a general form, x equals ay squared plus by plus c. The vertex can still be found using these same formulas, but h and k have switched places. So we would find k with negative b over 2a. Remember, k and y go together. And then to find h, we would plug in k for y in the equation above. And I'll write it like that. Since I don't have function notation, I can't write it as a function. And then we still end up with our vertex notation. So would be ak squared plus bk plus c, and k would be negative b over 2a. So that is something to be aware. They have switched roles. And similarly in the equation, we can write the equation a times y minus k squared plus h with the same idea for the function notation. Again, x's and y's have changed places, h's and k's have changed places. We can come back here to graphs 5 and 6 and see that for x equals negative y squared, a is negative 1, b is 0, and c is 0. So when we try to find k, negative b over 2a, negative 0 over 2 times negative 1, we get 0. And sure enough, our vertex was 0, 0. Similarly, for x equals negative y squared plus 4, a is negative 1, b is 0, c is 4, k is negative b over 2a, negative 0 over 2 times negative 1 still gets us 0. Plugging that back in to get h, though, 0 squared plus 4 gives me 4. So my vertex is 4, 0. We're just finding the y before we find the x. Now we can use the standard vertex form to find and graph the parabolas here. X equals y minus 2 squared plus 1. So looking at the numbers given, I see that a is 1, h and k are what I'm looking for. And since I have x equals, h is the 1, and k goes along with y, k is 2. So my vertex is 1, 2. Once I have my vertex, I can create my table, 1, 2, and I'm going to pick y values to plug in and find x. If you need to, pause the video, work these out on your own, make sure that you can plug in the numbers and simplify. For example, if y is 1, so I would plug in x equals 1 minus 2 squared plus 1. 1 minus 2 is negative 1, but if I square it, I get positive 1 plus 1 will give me 2. Graphing this, since my a is positive, I am getting a parabola that's opening to the right. Vertex is 1, 2, and axis of symmetry is y equals 2. And then last, looking at number 8, A is -2, identifying H and K. Remember that H goes along with X and K goes along with Y. So K is -3, opposite of what's inside the parentheses, and H is 1. So my vertex is 1, -3. This also means my axis of symmetry is Y equals -3 because I have an X equals equation. So I know I have a left-right parabola. The one thing also to notice, the parabola has only one variable squared. In this case, y is being squared. Before, when we talked about functions, x was being squared. This becomes important when you look at parabolas and circles. The circle equation has both variables squared. So that's a little foreshadowing into the next part of this lesson. We can create our table for this graph, x and y, 1, -3. I'm going to choose values for y and plug them in, -4, -5, -2, -1, and we can plug them in. Might take a little more work here, but we can do this. And just like our function parabolas, we have symmetry. This time it's present in the x values in the table for our parabola. Using our ordered pairs now, we can graph our parabola for number 8. I see that I'm opening left, and I'm going to have a stretched out parabola because of that 2. When a is bigger, the parabola gets stretched out more. If the absolute value of a is between 0 and 1, then we have a fatter parabola because it's being pushed down by the a value. So this one's being stretched out by the a value since the absolute value of a is greater than 1. And sure enough, there's our axis of symmetry right here at y equals -3. We've got our vertex here at 1, -3.